All right, guys, we're going to go through notes on lesson 3.2 and 3.3, where we're actually going to start solving inequalities. In the last lesson, lesson 3.1, we were just setting them up and we were graphing them. But now you're actually going to have a letter in the problem that you have to get by itself so that once it's solved, then you can graph it from there. So if you take a look at the first little part at the top, there's one thing that we're really going to have to be very cautious of in this lesson, and that is when you multiply or divide by a negative number, you have to remember to reverse your inequality symbol. So what I want you to write right here is that when you multiply, in that first blank, multiply or divide by a negative number, you must reverse the inequality symbol. So it's really important that we actually end up reversing the symbol because if you don't, not only is your answer going to be wrong, but your graph will end up facing the wrong direction as well. So if you take a look at a few examples, they're going to start easy and kind of get progressively a little bit harder as we get to some of the story problems. But just like we solve equations, we solve inequalities the same way. You're trying to work to get that letter by itself. In number 1, we're solving t minus 3 is greater than 5. I'm going to plus the 3 over to get that letter t by itself. And I get t is greater than 8. That letter t, the variable, is on the left-hand side, and that's what we want when we graph, because then when I go to put my circle at 8, I would use an open circle there because it's not an equal to line underneath of my symbol. And then the symbol right here literally points you to the right. And so when you go to do your graph, you can go ahead and shade to the right and always do the arrow on there as well to show that it continues forever and ever and ever. So that's what the graph would look like for number 1. If you take a look at number 2, for that one, we would work to get that letter x alone. So we're going to minus the 7 over to the other side. That cancels the 7 and gives us x is less than or equal to negative 7. And again, x is on the left-hand side. That's what we want. That way, when we go to do our circle at negative 7 would be right here between negative 6 and negative 8. My symbol right here, because it is it's an equal to, we would fill our circle in as well. And then it will literally point you where you need to shade. So it's pointing to the left. So I shade my graph to the left. After that, number 3, you'll see that the variable, the p, is on the right-hand side in this one. So as I work to get p alone, I'm going to do the same thing I would always do, just work to get p by itself. I'm going to plus the 1 over. 4 plus 1 on the left-hand side is 5. You can't just switch things around right now, okay? Keep the symbol less than or equal to, and then I have the letter p. At the end, when you notice that the p is on the right-hand side, then you can go ahead and flip everything. So I'm going to do the p. I have to flip my symbol too, though, so now my symbol is going to face the other direction and become a greater than or equal to, and then 5 on the right-hand side. And this would be my final answer. Because my letter's on the left-hand side here, that will actually point me the direction of shade. But if I leave my answer how I had it right before that, then my symbol would point me in the wrong direction that I need to shade. So I'm going to do my circle at 5. And it's got a line underneath for an equal to. So I'm going to fill this in. And then because it's pointing to the right, I'm going to go ahead and make my arrow and shading go to the right as well. After that, number 4, I'm going to work to get that letter G by itself. To get G alone, because it's a negative 5, I'm going to plus the 5 over to the left-hand side. So we'll cancel them out. Negative 5 plus 5 is 0. And then I have my symbol, and then I have G on the right-hand side. From there, because again, the letter's on the incorrect side, it's on the right, we want it always first on the left-hand side. I'm going to go ahead and flip this one as well. So G, and then I flip it to be a greater than sign, and then the 0. And then I'm going to go ahead and box that in for my final answer. Kids get really weirded out when they're dealing with the number 0 because they feel like the answer should be like no solution or infinitely many solutions or something weird like that. But 0 is still a number, and it's something that we can graph on a number line as well. So my circle at 0 will become an open circle because I don't have the equal to line underneath. And since my letter is on the left-hand side, the arrow in my answer will point me to shade the correct way, and it's pointing to the right. So there's my final graph for number 4. From there, number 5, we are going to work to get letter X by itself here. This one, we're moving from addition and subtraction. The 2 is smushed next to X, which means it's being multiplied. We work to get X alone by dividing by 2 on both sides. And we've got X, our symbol is greater than or equal to, and then 6 divided by 2 is 3. X is on the left-hand side already, so we're going to keep it as is. And my arrow is going to go at, my circle, is going to go at 3. It does have the equal to under the symbol, so I'm going to fill in my circle. And then we're going to shade, because it's pointing to the right, we're going to shade to the right. Okay. Number 6 is not a multiplication problem right now. Right now it's a division problem, and A is being divided by 5. So to get A by itself, we're going to multiply both sides by 5. We cross those off, and it leaves us with A, a less than, and then 1 times 5 is just 5. A is on the left-hand side like we like it, so we can go ahead and box that in. Our circle is going to go at 5, so over here I'm going to do an open circle at 5. And my symbol is pointing me to the left, so I can go ahead and shade on the graph all the way to the left from there. So far in any of these problems, I have not had to multiply or divide by a negative number, so I have not had to reverse my symbol for any of the problems yet. Okay, number 7, if we take a look at that one, kids get a little bit freaked out with the 3/4 B on the right-hand side because of the fraction. The 3/4 B is smushed next to the B, so it is being multiplied. Some kids will try to divide by 3/4. And it's okay to divide by 3/4, but it's kind of difficult to divide by a fraction. And sometimes our calculators don't do a great job of it either. So here's how I handle the fractions. This is really just a 3 on top and then a divided by 4 with the fraction there. So to get rid of a divide by 4, I can just times both sides by 4, and it gets that out of there. On the left-hand side, 4 times 3 is 12. I have my symbol. And then I still have the 3, and I still have the B left. So I'm just going to write 3, and it's smushed, so next to the B. Next, to get letter B by itself, I'm going to divide both sides by 3. So that cancels out. On the left-hand side, 12 divided by 3 is 4. And I have my less than sign, and then I have the letter B on the right. This time the letter is on the right-hand side. We don't like it there, so we're going to go ahead and flip it. So I'm going to make it B. I have to flip my symbol then as well, so it's going to become a greater than, and then the 4 will go on the right. When your letter's on the left-hand side, that makes graphing just so much easier. Okay, no room for error then. So you do an open circle at the number 4, and then from there our sign is pointing us to the right, so we shade to the right. Okay. After that, number 8. Number 8, K is being divided by -2, so to get rid of that, I do need to times both sides by -2. Now, this is the first time that we've encountered, if you take a look up here, where it said that whenever you multiply or divide by a negative number, you have to make sure that you reverse your sign. So I'm multiplying in number 8 by a negative number here. So I need to make sure that I remember to flip my sign here. I always make it really obnoxious for myself and put a bunch of stars. I'll do that on your quizzes and tests too, if you forget to flip. And then I write myself a little note here that says flip, because honestly, the biggest mistake that kids make, they know they have to flip it, but they just forget to do it as they're working quickly. Okay. So the -2's will cancel out. That gives me K. I take my symbol and I flip it around. So this is now going to be a less than sign. And then 1.5 times -2, that would be -3. My letter is on the left-hand side, just like we like it. And so K less than -3 is our answer. That means I'm going to do an open circle at -3. And my symbol here is pointing me to the left, so I'm going to shade to the left on my graph. All right. Number 9, if you take a look at this one, getting x alone, the -3 is smushed next to the x. So to get rid of it, we're going to have to divide by -3. Just like in the last problem, if you are multiplying or dividing by a negative, you have to make sure that you remember to flip your sign. So help yourself out, make it obvious. And if you need to, you can even go right away and flip it before you even do the math part. Okay, so the -3's are gone. I have x on the left-hand side, and then on the right, 12 divided by -3 is -4. My letters alone, it's on the left, that's what we like. So x is greater than -4 is my answer there. So my circle is going to be an open circle at -4. And then my symbol is pointing me to the right now. So I'm going to go ahead and shade to the right of that circle on my graph. All right, number 10, and then we're going to do a few story problems. Number 10, to get x by itself in this one, the -7 is smushed by the x, meaning it's times. So I have to divide by -7 on both sides. Cancels the -7s out. I just divided by a negative though, so again, I have to remember to take my sign and flip it. So if you want to do it ahead of time, you can. But I have x on the left. I flipped my sign. 0 divided by -7. 0 divided by anything is just 0. And again, that's one that kids will be like, well, is it a no solution or infinitely many solution? But if you actually type 0 divided by -7 in, it's just 0. And 0 is a number, and we can graph 0. All right, so close circle at the number 0. And then you can see that the symbol, because we flipped it, is now facing to the right. So I'm going to shade to the right of that circle on my number line. Okay, on to the story problems. Here we go, guys. Number 11, we're going to be setting these problems up, and then we're going to solve them, and we're going to graph these as well. So it says Joy wants to save at least $40 for her trip to Michigan Adventures. At least. That means one of our symbols in math. At least means that she needs $40 or more for the trip to Michigan Adventures. So if she needs $40 or more, that means greater than or equal to. Okay, so when you see that word at least, some of us, we see least and it's like it reminds us of the word less. And so a lot of kids will accidentally do less than, and then their problem is wrong, their solution is wrong, and the graph is wrong. So you have to be really careful with those. So far, she has saved $32. She plans to save D more dollars for the trip. We are going to be writing, solving, and then graphing the inequality that shows the values of D that will allow her to reach her goal. So because Joy starts with $32, I'm going to start my equation with $32 as well. And then she plans to save D more dollars. Now, more in math, if she's going to save more money, we're going to add to that $32. So I'm going to plus. And then they specifically said that she was going to save D dollars. I don't know how many that is right now, but that's what they said in the problem. And then the only other information I have is that it has to be at least $40. And we just got done saying that at least means greater than or equal to. So I'm going to make sure I do a greater than or equal to sign, not the one that looks like the letter L. And then the 40. So there's our inequality. That's us writing it. So we did that part. Now we have to solve it. Solving it means you got to show your work, get the letter by itself. So to get D by itself, we're going to minus 32 on both sides. That gives us D by itself. I don't need to flip my sign here because I only did addition or subtraction. And 40 minus 32 is 8. I box that in, my letter's on the left, that's the way we like it. Graph it. I'm going to put 8 in the middle. Always do a couple numbers to the left and to the right. To the right it's going to get bigger, so this might be 9 and 10. Left would be 7 and 6. I need to make sure that I do a closed circle at 8. And then my symbol right here, the greater than or equal to, is pointing me to shade to the right. There we go. So we wrote, we solved, and we graphed. All right, number 12 says the memory in Josh's camera phone allows him to take up to 1,200 pictures. Okay, up to 1,200 pictures means that 1,200 is the max that the camera can hold. If that's the maximum, then we have to stay under that. So we need less than or equal to 1,200 pictures. Less than or equal to 1,200 pictures on the camera. Otherwise, it's too full. Josh has already taken 516 pictures. And then again, we're going to write, we're going to solve, and we're going to graph this. Okay. So since Josh starts on his camera with 516 pictures, I'm going to start my equation with 516. And he's going to be taking more pictures. More pictures in math means that we're going to plus. And it doesn't tell us what letter to use, and we don't know how many more pictures Josh is going to take right now. I'm going to use P then for pictures. We know that he can only take up to 1,200, and we just got done saying that means less than or equal to, and then the 1,200. This is us writing the inequality. So we did the first part. For solving it, you're just getting the letter by itself. So to get the 516 over to the other side, I'm going to minus 516 on both sides. And that will give me the letter P by itself. When you type in 1,200 minus 516, you end up getting 684. My symbol stays facing the same way because I didn't do any multiplying or dividing with a negative. And my letter's on the left, so that'll make it nice and easy for us to graph. All right, so when I go to graph this one's a little bit tricky to graph because most people will say, oh, okay, 684. I need to make sure I have that on the graph. And they might put like 685 over here and maybe like 683 over here. And they do a closed circle at 684, which is correct. But then the symbol, they're looking at it and they say, oh, less or equal to, okay, that means I'm going to shade to the left, which that part is correct as well. But here's the deal. When you shade to the left, that means every single number to the left. So like 680, 500, 400, 300, 200, 100, 0 pictures. But it also includes negative 100 and negative 200 because all of that is also to the left. We can take 0 pictures and we can take 400 pictures and we can take 2 pictures, but we can't take negative pictures. So this graph right here is just not logical because the arrow means it goes on and on and on forever, all the way to the left. And all the way to the left includes negatives too. So we are going to draw or modify our graph so that it stops at a logical place. And 0 pictures is logical, and 684 pictures is logical. And we just said it can be less than or equal to that. So I'm going to put my dot back on there. And I'm going to shade to the left here, but I'm going to make it stop at 0 pictures. Because we can do anywhere in between there, but we can't go less than 0 pictures. It just doesn't make sense. Okay, so you want to make sure that with story problems, your graph is logical. If you look at the next problem, it says that Joe goes to the store with $15 to buy salad. Bags of pre-washed salad are on sale for $2 each. So he only has $15. Okay, if he only has $15, then I can't spend more than $15. So I need to stay less than or equal to. And then the bags of pre-washed salad are on sale for $2 each. Each was a word that we had focused on before because it means multiply. So we want to know the possible numbers of bags that Joe can buy for his salad. We're going to, again, write, solve, and graph this. So if we start with how much the bags of salad are, they are $2 each, we said means times. But we don't know how many bags of salad he's going to buy. So I'm just going to use B for bags of salad. We only have $15, so we have to stay less than or equal to that, so we don't spend over what we have, so less than or equal to 15. From there, we start solving. So we already wrote it, we just have to solve it now. To get B alone, we can divide by 2 on both sides, and that gives us B is less than or equal to 7.5. Here's the deal with this one though. 7.5 means that's how many bags of salad that Joe can buy, but we can't buy 0.5 bags of salad. You can't go to the grocery store and do that. So the 0.5 is not logical here. Okay, again, we're looking at logical answers with the story problem, not one that doesn't make sense. We can't round 7.5 up to 8 either, because if he buys more bags than he can afford, he's going to run out of money. So I actually have to round this down, and it has to be less than or equal to 7 bags of salad. So this is the logical answer. Decimals just don't make sense for this one. So when I go to graph this, I'm going to draw my number line. Most people will put 7 in the middle and then say 8 and 9 over here, or 6 and 5 over here. And most of you guys know to do a closed circle at 7 bags of salad. And because the symbol is pointing left, then we would graph it going to the left. But here's the deal. Again, to the left means all the way to the left, which is 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, and so on. And Joe can't go to the store and say, I want -3 bags of salad. So negative numbers are not logical here again. So we're going to actually cross that off because that number line is not accurate. It's not logical. So when I draw my new one, it is okay to buy 0 bags of salad if he goes there and decides he doesn't want any, but he just can't be negative. Okay, so 0, 1, 2, 3, 4, 5, 6, 7 would be right here then. I can buy 7 bags of salad. I can even buy 0 bags of salad if I really want to, but I'm actually not even going to shade in between all of this, because if I just make one big shading in between 0 and 7, that means everything between 0 and 7, but we already said we can't buy decimal bags of salad, so I can't buy 2.5 bags of salad or 3.2 bags of salad. So the way that you show that on a number line is that I can buy 0 bags, or 1 bag, or 2, 3, 4, 5, 6, and we already have our dot at 7. We can buy any one of those, but we just can't buy all the in-between stuff. So we make our number line look like a bunch of dots because decimals aren't logical here. So I want you to write decimals don't make sense here. And that's why we made our graph look that way. Because in a couple weeks when you come back to look at that problem, you're going to be like, what in the world? Why did we just do a bunch of dots for that one? And then for all the others, we did shading to the left or to the right. Okay, one more to go, guys. Number 14 says Elena has a gift card for a tropical smoothie for $16, where a smoothie costs $2.50 with tax. What are the possible numbers of smoothies that Elena can buy? So with this, she only has $16 with her. Kind of like Joe at the store only had $15 with him in the last problem. If we only have $16, then we have to stay less than or equal to $16 when we set this up. And again, it says smoothies cost $2.50. That's each, okay? Or per smoothie, you could say, which means we're going to times that. And we want to know what are the possible smoothies that Elena can buy. This one does not make us do a graph or anything, but we're actually going to because it's kind of a tricky one as well. So with this one, we're going to start with how much a smoothie costs, which is $2.50. Since that's each smoothie or per smoothie, we're going to multiply. And we don't know how many smoothies she buys, so I'm just going to use S for smoothies. But we do know that she only has $16, so we have to stay less than or equal to $16. From there, when I go to get S by itself, I'm going to divide both sides by 250. And when you type in S less than or equal to 16 divided by 250, when you type that in your calculator, you end up getting 6.4 for that. Okay. Now, obviously, Elena cannot go to the tropical smoothie and say, yeah, I would like 6.4 smoothies. So 6.4 is not logical. The 0.4 is not an acceptable answer here. And so then we would end up saying that our answer is S is less than or equal to just 6. Okay. This one's kind of like the last one because less than or equal to 6. If you think about what's actually less than or equal to 6, 5, 4, 3, 2, 1, 0, but there's -1 and -2 and -3 and -4 that are also to the left here. So I'm not going to do the graph where I cross it off again. I'm just going to go ahead and draw a correct graph. I know that I'm going to have my circle as 6. I know it's going to be filled in. But when I go to the left, I need to make sure that I stop my graph at 0 because it's not logical to go less than 0 when you're buying smoothies. I could, I guess, go there and buy 0 smoothies. It'd be kind of weird, but it's possible that I could go there and decide I don't want any smoothies. I could buy 1 smoothie or 2 smoothies or 3 or 4 or 5 or 6, but I can't buy decimals of smoothies just like I couldn't buy decimals of bags of salad. So again, our graph is going to end up being just a bunch of dots at all of the numbers, the whole numbers that are between 0 and 6. So that's what your graph would look like for that one. So the moral of the story with this lesson is if you multiply or divide by negative, you got to reverse your sign. And the other big thing is with story prompts, you have to be so careful that you are making logical graphs and logical answers as far as decimals go and going beyond 0 to into the negatives. You have to make sure it makes sense. Okay. All right, guys, I will see you later.